Hi there. This is a video that will help you on some of the problems on the study guide review to get ready for your test on chapter 1. And these are a couple of good problems that I thought might be helpful. Here's one, number 34, and it's a midpoint problem, but it's a problem where we are given the midpoint and we're looking for one of the endpoints. We're given an endpoint and a midpoint, and we're looking for the other endpoint. So the key to this problem is once you know you're given the midpoint and you're looking for an endpoint, it gets a little bit trickier than just finding the midpoint. So I'm going to underline the midpoint and really know that y is the midpoint so I can work. Now I'm going to work with these coordinates separately because this is the best way to solve this problem. I'm going to look at the x coordinate first. So I'm just going to write that down. I know I'm working with the x coordinate. And I'm going to come on over here and I've got my x coordinate of my midpoint. I underline that because that is the number that is going to the left of the equal sign when we write our equation to find the other endpoint. And so we've got -2 equals, and now I can start working with my endpoints. It's the average of the x's, which is -4 plus, we don't know what that one is, so I'm just going to keep it there, plus x divided by 2. Now we've got this interesting equation that we can easily solve for because we've done it once. We know that to get rid of that 2 in the denominator, we have to multiply both sides by 2. And that's what we'll do. And we'll get a -4 equals -4 plus x. Now we know we just need to solve, but we need to be careful because in this situation, we're going to get x equals -4 plus 4. Don't be afraid of that 0 in the answer. Sometimes people don't like to see 0 as an answer, but that's obviously a great x coordinate. Okay, so now let's go to the y coordinates because we're treating each coordinate separately. And we're going to look right at that midpoint first, and we're going to put that midpoint 3 on the left side of the equal signs, and then we're going to do the average of the y's. The average of the y's is the two endpoints, 4 plus y over 2. Now you can see how this pattern is working out. We've got to get rid of that 2 on this side. And we solve for y, and we get y equals 2. Now we didn't even have to graph it, but we just found the x and y coordinate, not of our midpoint, because we already got that, but of our other endpoint. So the coordinates of A, which is what they're looking for, are 0, 2. This is a great problem. It's the study guide review number 35. I love this problem. I'm so happy to show you this problem on video and on the test. So, we want to find the length of a segment, and this segment's graphed for us already. It's not graphed in your book, but you could graph it pretty quickly if you needed to. And the reason they want us to find the length of this segment with the graph given is because they want us to do it using two methods. And they want us to use the distance formula and Pythagorean theorem to find the distance between 2 points, which is the length of the segment that joins those 2 points. So what I like to do is I need to use this distance formula. It's an extremely useful and important formula that you will keep in your toolbox for many years to come. And this is the distance between 2 points is the change in the x's, x2 minus x1 squared, plus the difference or the change in the y's. squared. And we take the square root of all of that at the end. And this can get to be a little bit tricky, but as long as you are consistent with how you plug in your numbers and you're careful and you do each step, you'll get the answer and you'll start to get it right every time. So with a little bit of practice, we can do this problem pretty quickly. Now I've got my x's and I'm not even going to label them. I know what my x's are and I know what my y's are, and I'm going to subtract them. If I go in one direction with the x's, I will go in the same direction with the y's. And I can choose whichever direction I would like to go, but I think of it as a direction where I'm going to add the numbers into this formula. So here we go. I'm going to start with the x's, and I'm just going to go in this direction. I'm going to say -2 minus 6. -2 minus 6 squared. And I'm going to add that to the difference in the y's. Because I said -2 minus 6, I'm going to say 4 minus 1. So we'll do that. 4 minus 1, and we'll square. Remember, do everything in the parentheses, and I would write this step out. It's extremely important. That is a -8 squared plus 3 squared. And I like to write that step because I'll get it right every time. This is where no matter what sign your numbers are, they will end up becoming positive in this step, which means it doesn't matter which direction you go, you'll get the same answer. I've got a 64 plus 9. And I'm just going to leave this under the square root for now because my goal is to compare this method with the other method, the Pythagorean Theorem, and see if I get the same answer. As long as I can show I get the same answer, we're good to go. So we got 64 plus 9, and we've got the square root of 73. I'm just going to leave it just like that. Now, if it asks you to give your answer to the nearest tenth, you can do that if you want. But right now, we're just going to leave it here. Now, I'm going to verify this, and I'm going to show you guys something really cool. The Pythagorean Theorem, we all know, is a squared plus b squared equals c squared. Did you know that the distance formula comes from Pythagorean's theorem? And you'll start to recognize that actually, as we solve the problem using Pythagorean theorem, we're doing the distance formula, which is why this is a great problem, and I hope you carry this problem with you into your future. So here we go. A squared plus b squared equals c. Well, how do I get a, b, and c? Remember, because my graph is here, I'm just going to complete this as a right triangle. I'm going to go down as far as I need to, which is the difference in the y's. And when I get to the same horizontal line as the x's, I'm going to go over. Now, I could have made a triangle this way or this way, but I just need one triangle, and I need to get the lengths of the sides of that triangle, because we know this is C, and that's the hypotenuse across from the right angle. We need to know what are A and B. Does it matter what A and B are? As long as they are the two legs, you can choose either one. A squared, I'm just going to say, is the difference in the y's. So I'm going to say, how many did I go down in the y's? 1, 2, 3 units. And then I went over in the x direction, 8 units. I did the difference in the y's. I'm going to add the difference in the x's. So I'm going to do 3 squared plus 8 squared equals c squared. 9 plus 64 is starting to look very familiar. And that equals c squared. Now I'm almost done. 73 equals c squared, but I really want c. And so I take the square root of both sides, and c equals a very nice comparison. Both methods, the distance between those 2 points is the square root of 73, and I showed it both ways. process is very important in this problem because that's what will get you your full points. Have a great day. I'll see you back in class.